seen the first way to create a thread in Java. There's another way that's pretty close to the same thing. It does basically the same thing, but it does it in a different way. The way that we did this example is, if you remember, with our continuous printer, we had inherited from thread. We extended thread. And there's a couple of problems with this approach. The first one is that you can't inherit from anything else, so you're kind of limited here. You have to extend thread. And the second one is it's not very dynamic. It's not very reusable. If we use an interface instead, we can pass that interface around and we can write other methods and things that operate against that interface. It's a little bit easier to use, a more flexible solution. So that's what we're going to do for this next example. Is we're going to switch this over to use an interface called Runnable. And this is the key to concurrency in Java, is this runnable interface. There's a lot of things that operate on a runnable interface and can do something with the runnable interface. We're just going to show the simple example first here. And what we're going to do here is, instead of extending thread, we're going to implement runnable. So I'll change this to implements runnable. And then you can see that it's still going to have this same run method. The only thing is, we're not going to call this super run. Instead, we're just going to call run. And really, this class hasn't had to change very much at all. Now we're just implementing this runnable interface. And this runnable interface has a run method that you have to implement. That's the only method you have to implement. And since we've implemented that method, we're pretty much good to go from this perspective. Now, we do need to go into our main program, and we can't start it up the same way. We can't just call start on here because it doesn't have a start method. It has a run method. But what we can do is we can take our continuous printer and we can create a thread, and then we can pass this into the thread. So if I create a thread called thread, and then if I set it equal to new thread, in the constructor for thread, you notice you can pass in a runnable. So if I pass in a new continuous printer, or pass in this continuous printer that we created, then I've constructed a thread that's using this runnable implementation. And now I can call thread.start, and this will start this thread. So thread actually ends up being a wrapper to runnable. Whatever you pass in to thread, that implements the runnable interface. When you start that thread, it'll start. So let's go ahead and run this, and we should pretty much get the same result that we had gotten before. So I'll run this, and now if we look at this console output, you can see here the threads are interleaved. So this is another way of doing basically the same thing. The only difference here really is that you're using an interface instead of inheritance. And if you remember the modules that we had talked about using inheritance and why it's better to use aggregation, this is one of those reasons. Is we'll see a little bit later when we use an executor that it's going to use a runnable interface. And we have left our possibility for our continuous printer to inherit. It can still extend a class. So that's the basic solution, and I would recommend, if you're creating threads, that you default to this implementing runnable interface. It's just real simple. Just create your class, implement runnable, override the run method, and so now I want to show you kind of a powerful framework that you can use in Java to execute threads and to control the execution of threads. And really, this framework allows you to create threads and think of them as different pieces of work, or work items. And this is the executor pattern. And in Java, we can use an executor to basically execute our threads, but we can kind of set a policy by using different executors. The executor is going to use anything that implements this iRunnable interface. If you remember, with our continuous printer, we had changed this so that it implements this iRunnable interface, or this runnable interface. And using this runnable interface, it basically can behave like a thread when we had passed it to a thread. So we had used a thread, and we had done a new thread and passed in our continuous printer, and it was able to run it as a thread. With an executor, we can run the same thread, but we can have a lot more power over this. In fact, we don't have to run it multi-threaded. So this is a real advantage if you want to later reconfigure your application and control how the threading works. So I'm going to create an executor service. This is an interface here. We'll call this object executor. I'm going to import the namespace here. And then we're going to use this class called executor. And on this executor is this static class we have all these methods for creating new executors. And these are some of the built-in executors that exist in Java. You can always extend Executor or implement the interface and create your own. But in this case, we're just going to use some of these built-in ones because that's a little bit more of an advanced topic we're not going to get into right now. But let's go ahead and create an executor that is going to basically allow us to create what is known as a thread pool. So we're going to create a new fixed thread pool executor, and we're going to specify the number of threads. And let's specify it as 3 threads here. So what this is going to do is it's going to allow us to run a maximum of 3 threads at a time, and we're going to tell the executor what we want to execute. So we're going to call executor.submit, and then we're going to give it our Runnable interface. So in this case, our continuous printer implements Runnable, so we can submit it. And let's submit a bunch of jobs here. 3, 4, 5, 6. So we're going to tell the executor to run this 6 times, run 6 different threads here. And then at the end, we need to tell the executor to shut down when we're done giving it work to do. And what this will do is it'll go ahead and let us finish running the threads that are actively running, but it won't accept any more jobs. And this is just to know that it's done, we're done submitting jobs to it. So I'm going to run this, and before I run this, I want you to think about what's going to happen here. We're only going to allow 3 threads to run at a time. So how's this output going to look when we run this? Well, let's take a look here and see what happened. I'm going to scroll all the way up to the beginning, and you can see here we've got everything starting at 0, 0, 0, 0, 0. So we've got our main thread and 3 threads running, all starting at 0. Then they're all kind of running here, and it's kind of interleaved, but they're kind of staying roughly in the same count. Looks like one thread is getting a little bit robbed here. It's not getting enough time, but they're generally staying within pace. We can see we have 3 threads running. Now I'm going to scroll all the way down to where the main thread ends, where it's done. Now you can see what's going to happen here is, oh, what's this? We're starting at 0 again. So a new thread is starting up. And then as we're watching these run, you can see another new thread is going to start up here, and so on. And so what's happening from that output, you can tell that we're only running a max of 3 threads at a time. So we're getting the first 3 that are submitted. Those are running along with main, and then when those are done, it's running these next 3, or it's actually putting them in whenever there's an empty thread. The max threads that we're ever having at any one time is 3. Now what do you think will happen if I increase this to 10? Let's go ahead and clear this output, and we'll run this again. Now let's look at this output here. Scrolling all the way up to the top again, you can see now, see all these zeros, 1, 2, 3, 4, 5, 6 zeros that I see up here. So we're running all the threads at one time, and you can see it's interleaved with this main thread, and they're basically all running at the same time. And if I scroll down here to where the main thread ends, you can see there's not any new threads starting up. These other threads are finishing up, but nothing's starting up new. So that's kind of how that thread pool works, and we kind of got that for free. We didn't have to implement our own thread pool. It's kind of complicated to implement a thread pool. But these executors allow us to apply a policy to our threading. So for example, let's change this out, and instead of using a fixed thread pool, let's use an executor that is a new single thread executor. So this is only going to run everything in one single thread. So what do you think is going to happen when we run this? Let's go ahead and run this and see. Let's look at the output here. Starting up from the beginning here, you can see here that everything's running sequentially. You can see that it's running each thread from 0 to 99, and then it's starting the next thread. So what we've done here is we've been able to change the policy of how this threading happens in our application without really doing anything. We just changed out the executor. So that's really the value of using an executor in your code, and it's not that hard. All you have to do is make sure that you have something that implements Runnable, and then you can submit your jobs to this executor, and this executor service will run them with the policy that you specified.